Good morning, good afternoon, good evening, ladies and gentlemen, and in today's video we're going to be looking at arithmetic and geometric sequences. And in the next video we'll be looking at the series. So first and foremost, what is a sequence? So a sequence is a set of numbers that are arranged in an order. So let's say you had, I don't know, like 1, 3, 5, 7. This is something I would say is a sequence. Why? Because it's a set of numbers, 1, 3, 5, 7, and it's put in order from lowest to greatest. Now, given the general thing here, like what's going on with this formula here? Well, it's going from 1 to 3, 3 to 5, 5 to 7. What are we noticing about each time it goes to a different number? Well, 1 to 3, it went up by 2. From 3 to 5, it went up by 2. And from 5 to 7, it went up by 2. So the difference between each one, or you can say the common difference, is 2. So that brings us down to what the actual formula is for a arithmetic. We're going to start with arithmetic here. So an arithmetic sequence, let's say we're looking for the nth term here. So the nth term, to determine the formula, would go under this kind of formula. So t of n is equal to a plus n minus 1 d. A is the first term of a sequence. While d is your common difference. Okay? So, if you're looking into this example we talked about above, what's my first difference? Well, you can see like my first term would be the 1. And you can see each one is basically an addition times the common difference. So if we were to put this into a formula, it would look like this. It would look like t of n is equal to 1 being my first term plus n minus 1, and of course my d is 2. Okay, so if I were to expand this out, we'd have 1 plus 2n minus 2. Common terms together, 1 minus 2 is negative 1, so you have 2n minus 1. So let's test this out. Let's say I wanted to find out this term, but I don't know it yet. This would be my second term. So if I were to try out okay, so I want to find out what my second term is. So you have t of 2 is equal to 2 times 2 minus 1. 2 times 2 is 4, minus 1 is 3. You can see I got 3. And if I wanted my third term, well, you'd try n is equal to 3. 2 times 3 minus 1. 6 minus 1 is 5. So as you can see, the formula works for every single term inside this sequence. So let's take a look at some examples. Okay, so in this first example, we're going to take a look at what would happen if we looked at, given the formula, and they want you to write the first 4 terms. So that basically means they want you to solve this equation when n is equal to 1, 2, 3, 4. You can have 4 different numbers. So t of 1 is 3 times 1 plus 5. 3 times 1 is 3 plus 5 is 8. T of 2, 3 times 2 plus 5. 6 plus 11 plus 5 is 11. T of 3, 3 times 3 plus 5. 3 times 3 is 9, plus 5 is 14. And t of 4, 3 times 4 plus 5. 3 times 4 is 12, plus 5 is 17. So my first 4 terms would be 8, 11, 14, and 17. So what if instead, now I'm asking you if you had this formula, so example 2. So given I'm telling you it's an arithmetic sequence as well, Tn is equal to 2n minus 5. Find T10. Okay? So I now have given you that your n is 10. Okay, so I want T10, which means 2 times 10 minus 5. 2 times 10 is 20, minus 5 is 15. So all pretty straightforward so far. Let's take a look at another example here. So if we go into another example, like how we started, let's say I give you a number sequence here, 5, 9, 13, 17. Let's try to make a formula here. So what is my common difference? Well, from 5 to 9, that's 4. From 9 to 13, that's 4. From 13 to 17, that's 4. So I know my D is 4. And my first term is 5. So if I were to make the formula, first term, 5 plus n minus 1 times 4. Let's expand this. And collect my like terms. And that is my formula. What if now we expand this and say another example where I told you how many terms are in this sequence. So let's say I gave you 1, 4, 7, and da 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 da, and I told you this last term here was 121. So I don't know what term or how many numbers it takes to get to 121. I do know my first number is 1. That's my first term. And I do know from 1 to 4, I added 3, and from 4 to 7, I added 3. So I know D is 3. So if I were to make my equation, I am looking for when I get 121. Okay? So using my formula, I know my first term was 1 plus n minus 1 times 3. I don't know what n is, so I want to solve this. So you expand and do what you can. 121 is equal to 1 plus 3n minus 3. Collect your like terms. Bring the 2 to the other side. You'll get 123, and then if you divide both sides by 3, you should get 41. So that means there is 41 terms here. right. Let's go one more example here for arithmetic. Let's say I gave you T5 is 16, T8 is 25. So how would I find my stuff? Well, for this case here, you'd have to make two equations, because I don't know what A is and I don't know what D is. So I know T5, which is 16, but I do know that you have A plus, I know my N would be 5, don't know what my D is. So if I were to expand this, 5 minus 4 would be 4. So you'd have 16 is equal to A plus 4D. That's one equation. And for the second equation, we know T of 8 is D. So you can make from that 25 is equal to A plus 70. Okay, so that's your first, that's your second. And from there, you can just do a sequence of series here. You can actually do solution here by elimination. So we can add the two together, or we can do, let's label these. So let's say this is equation 1, this is equation 2. So let's do equation 2 and subtract equation 1 from it. So we're going to be solving this through elimination here. So I'd have 25 minus 16 is equal to A minus A plus 70 minus 40. Okay, so A minus A, that's going to cancel out. You're going to get 25 minus 16, which is 9. A minus 8 cancels out. 7D minus 40 is 3D. So D, 9 divided by 3, would be 3. Okay. Let's just separate this off here. So we've gotten our D. Now with our D, you can put this into any equation you want. You can put it in pretty much anywhere. You can put it in the first equation, put it in the second equation, find out what your A would be. Okay. So let's just put it in, let's put it in the first equation, because yeah, it's all right. So sub that into it. So you're going to have 16 is equal to A plus 4 times 3. So 4 times 3 is 12. So A would be equal to 4. Okay. So therefore your final equation would be 4 plus n minus 1 times 3, which you can simplify out into 3n plus 1. And that covers the arithmetic part. So let's take a look at geometric. So in a geometric sequence, we looked at arithmetic and we noticed that it had to do with addition and subtraction. But if you'll notice here, there's no addition from here to here. So what do you notice? Well, this one goes up by 4, but this one goes up by 12. Oh my god. So they definitely don't have anything in common in terms of a common difference. But if you'll notice, 6 divided by 2 is 3. And 18 divided by 6 is 3. So what am I noticing here is that in this case, I would say they have a common ratio, not difference, ratio. Because now we're doing things with division and multiplication. So if I wanted to go from 2 to 6, I have to do 2 times 3. If I wanted to go from 6 to 18, I'd have to do 6 times 3. So I have to multiply each number by the same thing. So in this case, I'd say my common ratio is 3. Okay? And that brings us to the general equation. And the general equation would be t of n is equal to, take your first term, multiply by your r to the power of n minus 1. Of course, a is your first term, and r is your common ratio. So in this case, my first term would have been 2. So if I were to write my equation, t of n is equal to 2, and 2 is always being multiplied by 3 each time. Now, unlike with the arithmetic sequence, you don't really have to multiply this out and get your simplified form here, because this is as simplified as you can possibly get here. And you'll be done. So let's take a look at some examples. Okay, just like what we did with arithmetic, we're going to do the same thing for geometric. So I give you an example where you have the formula and they want you to get the first 3 terms, which means n would be 1, 2, or 3. Okay, so t of 1 is equal to 5 times 2 to the power of 1 minus 1. 1 minus 1 is 0. 2 to the power of 0 is 1. So t of 1 would be 5. Okay. T of 2. 5 times 2 to the power of 2 minus 1. So that's 5 times 2. Which is equal to 10. And finally, the third term, 5 times 2 to the power of 3 minus 1. It's going to give me 5 times 2 to the power of 2, which is 4. And that's 20. So my first 3 terms are 5, 10, and 20. Now, let's say I give you another example here. Let's find a formula here. So let's say I gave you 3, 9, 27, 81. Find the sequence formula. Well, what am I noticing? 3 times 3 will definitely give me 9. 9 times 3 will give me 27. 27 times 3 will give me 81. So that means r is 3. And of course my first term is 3. So my formula here would be t of n is equal to 3 times 3 to the power of n minus 1. And if you wanted to test that out, if you want to check, you can try it out. So like if I put, for my first term, I should be getting 3, right? So when t of 1, you put 3 times 3 to the power of n minus 1. I know that the n is supposed to be actually 1, so you go 1 times 1. So 3 times 3 to the power of 0, which is 1, so 1 times 3 is 3. So it works out. Alright, let's take a look at 1 or 2 more examples. So just like we did before, We have a set of numbers. I want to find out how many terms I have. So I know my first term is 3, and I know it's going up by a multiple of 2 each time, because you go from 3 to 6, which means 3 times 2 is 6, 6 times 2 is 12, and so on and so forth. So R is 2. Alright, so let's make our formula. Now, I want to get to 384. Okay, so you want to isolate here. So divide both sides by 3. So 384 divided by 3 is going to give me 128. And now this turns into one of those old exponent problems we used to look at. So remember, our first step would be isolating and making sure that this becomes the same base as this. So I want that to be 2 to the power of something. So just in case you guys forgot, remember you do prime factorization. 5 by 2 will give me 64. By 2 will give me 32. By 2 will give me 16. By 2 will give me 8. 2 give me 4. And 2 will give me 2. So how many 2's do we have here? 1, 2, 3, 4, 5, 6, 7. Okay, so this is 2 to the power of 7. 2 to the power of n minus 1. We have the same base, which means I can just equal out my exponents. So n is equal to 8. It's a little bit more involved, obviously, than the arithmetic. Okay? So let's take a look at another type of example. Let's look at the same type with different numbers. Okay, so we're looking at some big, huge numbers here. So how do we do this? Well, let's find our A. Well, our A is the first term, so there we go, found it. And if I want to find my common ratio, it's best to do your second term divided by your first term. And you're going to find out that you can simplify this as 1 over 3. So my R is 1 over 3, first term. So T of n is equal to 52,612,659 times 1/3 to the power of n minus 1. Of course, I know that this n t to the n was 11. So we're going to be doing the same thing we did before. We're going to do 11 divided by 52,612,659. Okay. I can also simplify this as 1 over 4782969 is equal to 1/3 to the power of n minus 1. Let's bring this over here and continue. Alright, so if I brought my 1/3, I can make this 3 to the power of -1. n minus 1 is equal to let's bring the bottom up as well down there, so let's make this 4782969 to the power of -1, because that's how you bring it up. So I want to get these to be the same base. So if you prime factor it the same way we did before, you're going to find out. So first let's expand this actually. So you're going to get 3 to the power of negative n plus 1 is equal to. This, if you keep dividing it, you're going to find out it's 3 to the power of 14. Or negative 14 in this case. Okay? So, bases are the same. So you're going to have negative n plus 1 is equal to negative 14. Let's turn some things positive here. So you're going to get n is equal to 14 plus 1, which is 50. So again, a little bit more involved, but same conclusion. Let's do one last example. Alright, so final example. Just like we did when we did arithmetic, you're going to have to make 2 equations here to find your 2 unknowns, because I don't know what my a is, I don't know what my r is. So let's make our first equation. My first equation we know T5, so T5 is 1875 is equal to A times R to the power of 5 minus 1, which I know is going to be 4. Okay. Second equation, you're going to have 46,875 is equal to A times R to the power of 7 minus 1. So you're going to have A to the power of R to the power of 6. So before we did equation 2 minus equation 1. That's when we were talking about arithmetic, but in geometric we know it has to do with multiplication and division. So in this case we're going to do equation 2 and we're going to divide it by equation 1. Okay, so you're going to have 46 I have a typo there. So that should be 46,875. So 46,875 divided by 1875 is equal to AR to the power of 6 divided by AR to the power of 4. Okay? So 46,875 divided by 1875. It's going to give me, what's it going to give me? It's going to give me here, let's do some division. So you're going to have A divided by A, these cancels out. Then you have the same base. So these two are going to subtract as per our exponent rules. So R to the power of 6 minus 4, which is 2. Right? And 46,875 divided by 1875 will give me 25. So R is, take the square root of both sides, 5. Now, obviously, when you take a square root, you're going to get positive and negative answers. You only want the positive answers here because, obviously, the negative answers do not make sense. So, just like we did before, let's then substitute this pretty much anywhere you want. Could put this into your first equation, put it in your second equation. I'm going to choose to sub it in my first equation. So I'm going to have 1875 is equal to A times 5 to the power of 4. Okay. So A should be equal to 1875 divided by 5 to the power of 4. So A is equal to 3. So therefore my equation would be T of n is equal to 3 times 5 to the power of n minus 1. And that is arithmetic and geometric sequences. Hope you have understood and enjoyed this video, and have yourself a wonderful day.